My name's Ed Thomas, and I am not now, nor have I ever been a meteorologist or a scientist or a climatologist, but I have slipped in here because I have worked a lot of disasters when I worked for FEMA, a couple of hundred disasters. I'm an attorney, and we're going to ask each of our panelists to introduce themselves as briefly as that, to provide extra time for questions, comments, thoughts, and ideas. I'm here representing the Natural Hazard Mitigation Association. This is, of course, not legal advice. It's a statement of general principles of policy. We're going to be talking about how to reduce the toll of foreseeable natural disasters. We're going to be talking about what we are doing, and most especially what we are not doing as a nation to make things different and better for the economy, for the people, and for the environment. Natural Hazard Mitigation Association was created to fulfill a need that was identified actually earlier today, this morning in this very room, to cut across the cylinders of excellence, to bring together different people who are involved in trying to make our society safer. Academics, students, practitioners, scientists, attorneys, planners. And we'd love to include more of you. I wonder if all of you in this room can agree that we will not have an economy or a sustainable economy, or for that matter, any economy at all, unless we can deal with having safe places for businesses and industry to operate and safe places for people to live. Everybody pretty well on board with that? Does that sound like it makes sense? Hazard mitigation is plain common sense. I really wish I had a quotation from a United States leader to put up here, but I have a quotation from the UN talking about disaster risk reduction is not a luxury. It's fundamental. We have to have a safer society. We have lately done incredible strides on doing a better job of response and recovery, and that is critically important. I spent a good part of my life doing disaster response and recovery. But I'll tell you what I have learned, that there is one single best form of disaster response and recovery, and that's no disaster response and recovery, because we've accepted the foreseeable processes of nature and built accordingly. There will always be black swan events, something a little bit bigger, something a little bit worse, yet we can foreseeably prepare for many, many things. There's no question that wind, flood, earthquake, wildfire losses are increasing and increasing dramatically. There's no question that more and more people will be in harm's way, as we heard this morning. Even more challenges from the reality of sea level rise, and then if this climate change thing turns out to be correct, even more challenges. Trends in flood damages going up in constant $2,005, soaring over the past decades. Flood, wind disasters increasing most of all. These are numbers thanks to the Munich Reinsurance Company. Thank you, sir. Demographic trends, more and more people in harm's way. And yet we will see opportunities because, according to demographers, more than half the built environment that we'll see in 2030 or 2025 did not exist in the year 2000. We're making changes as a society based upon economic and demographic pressures. We can still get this turned around. So another question for the group. Does nature cause disasters? In my longer lectures, I often talk about my client, Mother Nature, and how she's been maligned and viciously attacked for these so-called natural disasters. One of our nation's great thinkers, late great Dr. Gilbert White, said that floods are acts of nature, yet flood losses are largely acts of man. We have met the enemy, and he is us. Mother Nature should not be blamed for failures of engineering, failures of architecture, failures of community development. We can do things differently and better. We'll always have black swan events, but most of the stuff can be taken care of. The U.S. is making some excellent progress. Tim Manning from FEMA talked about that earlier this morning. Excellent progress being made, yet we really need a clear statement that foreseeable natural events are getting worse due to what we are doing every single working day. We need to do things differently and better. And are we adapting? Well, our coasts used to look a little different than they do now, and it doesn't look like adaptation is what's going on. What we're seeing is more economic pressures driving more and more construction in these areas, and much of it is not safely designed and built. The Army Corps of Engineers has pioneered the idea of what they call flood risk management, driving down the residual risk of development. And they suggest building codes and zoning, levies, outreach, insurance, a whole lot of ways of driving risks down. But let me make one thing perfectly clear. That's not what we are doing as a society. We're starting with an initial risk and making things worse with poorly designed construction that doesn't have adequate warning, doesn't have adequate research, doesn't have adequate design going into it, ending up with a vastly increased residual risk on our coast and in our inland areas. We need to get the idea across that safe development is affordable. Karl will be talking more about that, Karl Hedde from Munich Reinsurance. There are studies out on this, on affordable design, and we need to convey the message that when we talk about climate change adaptation, or what the folks in my field talk about as hazard mitigation, it's not to say no to development. It's to say yes to good, sound, proper development. The choice of development or no development is a false choice. We need to recognize that even the most conservative commentators are suggesting that climate change, global warming, are going to make things worse, and that we need to have public policies that will reward good, safe, proper construction. Now, I lecture all over the country. One of the things I have learned is that there are an enormous number of people in this nation of ours that are not climate change deniers. They accept climate change. They know exactly what it is. There is no question or doubt in their mind what it is. It is a vast left-wing conspiracy that has to do with funding Obamacare and also eventually taking away their guns. There is no point in arguing with them about that. It's a no-win. What you have to do is approach them, talk about the uncertainty, talk about the great American philosopher Yogi Berra, who pointed out to us that prediction is very difficult, especially when it's about the future. Talk about not so much sustainability, that's become a bad word too, along with climate change. Talk about resilience. Talk about the national security. Find a different message and not fight with them about climate change. To tell them that the fundamental principle of emergency management is to hope for the best, but plan for the worst. To be ready for the black swan events, for development decision-making, planning, and emergency preparedness. To also recognize, I'm an attorney, I lecture widely on higher standards, on regulatory standards, and the law. To recognize that climate change adaptation does not necessarily mean setback, that it can include properly well-designed buildings with respect to elevation that can serve multi-purposes, including evacuation shelters in areas that otherwise wouldn't have them. There's a lot of people working on this, from the Chamber of Commerce to FEMA to many other folks. But I hope all of you, if you haven't read this, will take a look at this important FEMA publication that talks about a whole community approach to this. That includes the scientific community, the insurance community, everyone involved in changing the way we are doing business. And I suggest that the American Bar Association has some thoughts that may actually help us with this. And it talks about having a system of universal catastrophic coverage as part of your insurance policy, and then making that affordable through a system of zoning and building codes and other ways of reducing the risks and consequences. And I'd like to follow up on that as I conclude here with three thoughts. We can do this. The thoughts are, believe it or not, the reduction in our incidence of aircraft accidents, the reduction in the incidence of urban fires, and a study on the payback that was studied by the Wharton School, done on the payback of higher standards on one of our most flood-prone coasts. In the early 1950s, the U.S. government did a study on how much we're going to see air traffic increase. And they called it very, very, very correctly. And they predicted that if we had the current rate, 1950s rate of airplane incidents or accidents, we would be seeing an aircraft accident about every week as we saw the air traffic soar into the future. And we don't regard airplane accidents as a natural disaster. We ruthlessly track down the cause and we correct it. And that has resulted in a tremendous diminution in the rate of airplane incidents, even as air traffic has increased. So too with urban fires. FEMA has an excellent publication on that. Talks about America Burning, Recommissioned. Talks about how 100 years ago, America, the United States of America, was one of the worst nations in the world for dealing with urban fires. And over a period of about the last 100 years, we have worked together with an economic basis to improve local building codes, local zoning, to motivate local governments to compete with each other, not to drive down standards, but to increase standards in order to get what was referred to this morning in the brilliant presentation by Kristen Jacobs as to turn around and give people discounts, to give people money through lower insurance premiums. It works. Wharton School study pointed out that with higher floodplain management standards, that it would be possible to so drive down the risks and consequences of a disaster, even on the horribly hurricane-prone Texas coast, that you could make insurance affordable. Fundamentally, we as a society are going to choose to continue to do things the way we are doing now, which will inevitably lead to misery, environmental desolation, serious damage to the economy, and litigation, or to do things differently and better. Every single person in this room can play a role in that, and I hope that you will. I hope that you'll also think about the Natural Hazard Mitigation Association, and we'll be doing questions and comments at the end after everyone has spoken. So now I'd like to turn this over to our next speaker, who is Tom Karl from NOAA, and I'd like Tom to introduce himself. Thank you, Tom. Thank you.
Thank you, Ed, and I'm pleased to be able to talk a little bit about one of my favorite topics, and that is, what are we seeing in the climate with respect to changes and variations in extreme weather and climate events, to give you a little bit of perspective. I do, however, want to start out by providing a bit of motivation, as if we need any, about some of the economic aspects of the major weather climate disasters that we've seen. A lot of input from people like Munich Re, Property Claim Service, the number of federal agencies, USDA, FEMA, trying to assemble a number of statistics about the weather and climate extremes as they have impacted the U.S. Then we'll talk about the state of science on some of the extreme events, and then just do a wrap-up summary, and we'll try to keep this 15 minutes or less. This was 2011. The circles show you the kind of weather climate phenomena that was associated with a $1 billion event. We had 14 such events. You can see the circles there represented by tornadoes, heat waves, droughts, blizzards, hailstorm events, flooding events, both river flooding, hurricane-induced flooding. So we had the full spectrum of events last year. And if you ask, well, how does this compare against the years past? I might add there is a workshop later this week in Asheville, North Carolina, to take a look at this data and to see whether it is useful to look at a time series in these data, because We want to make sure we're not seeing just changes in reporting practices. But in any case, you can see the large number, $14 billion events in 2011. That solid line, red and blue line, shows you the actual damage. 2005 with Katrina, just the total damage was disproportionate to other years, and the red line shows some of the adjustments for inflation. So as if we needed some motivation, understanding that obviously is important. But one of the questions that we asked, we had a series of workshops where we invited a number of experts. We had, you'll see the titles of the topical areas we've addressed on the right. One, monitoring and understanding changes in extreme storm statistics, monitoring and understanding heat waves, cold waves, floods, and droughts, and then monitoring and understanding extremes and extreme winds, waves, and extratropical storms across the coast. A number of experts gathered. Papers have been accepted now. One of them is in review. The other one is about to be submitted. But the diagram on the left, and we actually have redone this diagram. You'll see high, medium, low. It should say more pointing to the top and less pointing to the bottom. We didn't want to get people the impression that, if we're in a green area, everything is fine. But I didn't have time to change the slide, unfortunately. But what you'll see for events like extreme precipitation, heat waves, cold waves, our ability to detect changes over time, and our ability to really understand the decadal factors that may be responsible for those changes has got more understanding than comparison to, say, on the lower left, ice storms, winter ice storms, or thunderstorm-induced damaging winds, where we have less ability to look at changes and less understanding of what we might look for in terms of decadal changes. So this is an example of trying to understand where you might want to put research, where you might want to put extra monitoring, so if those phenomena in the lower left, for example, are important, particularly for economic impacts. Here I wanted just to show you, I want to go through what's happening with some of these events. We talk about heat waves. Here's a look at U.S. annual maximum minimum temperatures. The way to read this diagram, this goes back to the early part of the 20th century. It has a series of bars and a smoother on it applied for maximum, mean maximum temperature, mean minimum temperature. And it shows the percent of the U.S. that's much above normal on the left, reading down, and the percent of the U.S. that's much below normal on the right, reading down. And as you can see, the only graph that's not statistically significant in terms of changes is the upper left. That's the maximum temperature. Although we have seen more high temperatures because of the 30s being very dry in the 50s, the mean maximum temperature, much of the country, much above normal. But you look at all the other statistics, mean minimum temperature, the frequency of being much below normal, those are all significant and going in the directions you'd expect of a warming climate. If we look at what's happening globally, this is some work that Jim Hansen is just about ready to publish, but he's used his data set. He's got a global data set. Very similar answers you get out of all the different global data sets that are out there for temperature. If you look at the 1951 to 61 period and compare the frequency of standardized or normalized temperature departures from normal for each decade across all the grid cells, these are 5x5 grid cells, in the northern hemisphere for the summertime period, you can see pretty close to a bell-shaped curve, 51 to 61, centered around 0. And if you go to the right, you see the purple curve, which is the most recent decade, 2001 to 2011. There's about a 35% greater likelihood of having a 2 sigma or greater departure from normal compared to what we saw in the 50s. So clearly, and you see even some 5 sigma events being more frequent. Important information with respect to extremes. Just going back to the U.S., looking at the frequency of one-day heavy precipitation events, downpours. Look at the last couple of decades. This goes back again to the beginning of the 20th century. You'll see elevated last couple of decades, more extreme heavy precipitation events. If we try to say, do we understand why that might be happening? This is the difference between the last 2 decades and the previous decades. On the left is looking at different regions, and the dark green is where we're seeing statistically significant increases in extreme precip events. And if we look at changes in precipitable water, how much water is in the atmosphere in these areas, during the time when we had these events, you'll see all areas green, meaning there's more precipitable water. Those areas that are shaded dark green, statistically significant increase. We think we have a good understanding of what an important driver here is, and that's more water vapor in the atmosphere. And we all know warmer temperatures lead to more atmospheric water vapor. One has to be careful. I showed you that diagram with extreme one-day precipitation. There's been a discussion in the literature, well, are we seeing more floods? And on the left is data from the United States Geological Survey. Also, as part of this workshop, we had experts in floods from the standpoint of stream flow data. On the left, you'll see these triangles colored green for positive changes, colored brown negative changes for stream flow. The top and bottom figure on the left are exactly the same. They're just reproduced twice. And if you compare that to the figures on the right, there's two different figures. One is the total annual precipitation, and the other one is a measure of drought index. You'll see the green areas where we've seen more precipitation over the same time period correspond to where we see more flooding. Where you see brown areas in the southwest and parts of the west, you see trends in flooding going down. So why is that important? Because we just said the extreme one-day precipitation is increasing virtually everywhere in the U.S., some areas a lot more, but we're not seeing a corresponding increase of riverine flooding everywhere in the U.S. Well, what's happening is the extreme one-day precipitation changes are being driven by the warm season precipitation. And often for these floods with our river-induced, these are early spring or mid-spring kind of phenomena, and by the late summer, the rivers tend to be at their lowest point, early fall. So it's important to understand the seasonality. If you look at drought, the 30s and 50s stand out, although we have had some major droughts in the last few decades, 1900 to 2010, this data go from. And again, if you want to argue there's been no change, just calculate a trend back to 1900. If you want to say droughts are decreasing, go back to 1930. If you want to say they're increasing, start 1970s, where we didn't see a lot of droughts. A lot of decadal variability here. Put this diagram up because this is a projection of the future. It's the only projection of the future that I've got in this slide deck. But the big message, take-home message, if you look into the late 21st century, if we look at almost every scenario we have with more greenhouse gases in the atmosphere, wetter in Canada, drier in the subtropics. And where does that put the U.S. kind of in between? Hard to say what's wetter or what's drier. Although there is a tendency for the Southwest, it looks like here, and perhaps the Northeast to be wetter. Interestingly enough, last year might have been an interesting scenario if this were ever to play out, where this index looks at the combination of areas in the U.S. that have extreme drought or extreme wetness. And you'll see in 2011, over 55% of the nation was classified in either extreme wetness or extreme dryness. And that even exceeds the 1930s. In 1936 in particular, much of the U.S. was in extreme drought. The difference last year was part of it was extreme wetness, and part of it was extreme drought. And this is an example of how one should be cautious in looking at projections in the future and trying to understand what they would mean for important events like extreme snowstorms. On the upper left, you'll see what we did is we looked at the 5 most extreme snowstorms in each of those regions that are colored. And you can see by decade, starting in the early 1900s and going to the first decade of the 21st century, the frequency of extreme snowstorms across the U.S. And you'll see certainly a greater number in the 80s and 90s and significantly smaller number in the 2000 decade, 2001, 2010. Interestingly enough, we looked at when those storms occurred, what was the mean winter season temperature. And it's interesting, the mean winter season temperature was below normal, as you might expect. However, 2 of the 5 storms of record in each region occurred during winters that had above normal temperatures. So the message there is be very careful about your expectations about extreme snowstorms in the future, because some of them may, in fact, still continue on even as the climate warms. We want to just end with this data. Some of our data are not very good, like here's an example of tornadoes and convective storms to try and say what's going on. We had a lot of those events last year. However, there's promise. Here's a recently published paper by Malamud and Turcoti, 2012. Very interesting. Instead of looking at the number of tornadoes, looking at the path length of tornadoes on the ground. These are data that are measured much more objectively, and you can see some interesting trends going on there. So I think there'll be a lot more looks at this data, see how we can make use of it. And with that.
Good afternoon, everyone. I'm Frank Boteler with the National Institute of Food and Agriculture. We're basically one agency within USDA primarily responsible for funding extramural research. The agency's budget is about $1.3 billion. We fund research, education, and extension efforts by awarding grants primarily to the land-grant universities, but also to other partners. And what I'd like to do today is talk about some of the challenges that changing climate variables pose to U.S. agriculture. First of all, I want to begin with a caveat and caution you not to think in single-dimensional terms. For instance, since temperatures are increasing, as we just heard, that has this effect on agriculture, or since precipitation patterns are varying, this has that effect. Agriculture in the United States is a dynamic, self-adjusting system that is constantly responding to changes or fluctuations in trade, policy, markets, technology, and climate. And agricultural producers, farmers, ranchers, foresters, for instance, are constantly responding to these changes. So it's a very dynamic system. What the trend in climate variables poses to agriculture is perhaps a more of an ongoing change to some of these climate variables over time than we've seen in the past, and that's where much of the challenge is. What are the three significant climate variables that are affecting agriculture? Well, in fairly basic terms, changes in temperature, changes in air quality, and changes in water availability. In regards to changes in temperature, as Tom just reviewed in much more detail than I will, generally in this country and across the planet, we're seeing an increase in temperature as reflected by the upswing in the red charts there. These aren't projections, these are actual recordings from NOAA data. Also, the black line there is we're also seeing an increase in carbon dioxide. Both the change in temperature and increase in carbon dioxide have significant implications for agriculture. Specifically, the changes in temperature essentially put more energy into the climate system, thereby decreasing its stability and previous predictability. And certainly this spring and late winter, we're seeing examples of that, departures from past patterns of what we regarded as, the coming weather. In agriculture, that means significant challenges to risk management because farmers, ranchers, foresters have to project ahead when they make their investments in planning. We're also in this country seeing significant changes in water availability, with some portions of the country seeing more water, particularly in winter. Other portions seeing dramatic decreases in water. For instance, in the southwestern United States, very, very significant drought. These precipitation amounts have particular effects right now in the northwestern portion of the United States, in that much of the agriculture in that region relies on irrigation. And basically what we're seeing in terms of climate variables is more condensed winter precipitation over a shorter amount of time and less summer precipitation. The current water impoundment systems that save that water for irrigation in summer may not be able to deliver that much water in the future. Has demands on that water increase, the price of it's likely to increase. So the downstream effect on that is probably quite a dramatic effect on the profitability of irrigated agriculture in that region, and therefore farmers having to adjust the crops they plant. In terms of some projected impacts on plant and animal systems, and they're kind of countervailing forces of some of this. The planting system and planting season in general in this country has increased 4 to 16 days since 1970, largely due to the increased temperatures. On the other hand, there's been a significant decrease of about the same amount, 3 to 4 days anyway, in workable field days due to having wetter springs. So kind of countervailing forces in that way. In regards to some general effects of climate variables on plants and things to consider, pollination is very sensitive to temperature. So you might think, well, what's the big difference of a change of a degree or two in, say, in corn? It's a huge change at that pollination time. If there's a change in that temperature, whether that particular variety of corn will successfully move forward into the future. And that's one of the, most crops are in that kind of condition. Something you might not be aware of, warmer nighttime temperatures have particularly dramatic effects on grain, fiber, and fruit production. And of course, we're seeing increase in warmer nighttime temperatures. Increases in carbon dioxide generally increase plant growth. Not everything in terms of the projections of climate change are bad for agriculture. Forests, for instance, in this country are projected to grow a bit faster. And in particular, weeds and invasive species will probably grow faster in response to increases in carbon dioxide. In terms of animal agriculture, dairy production is extremely sensitive to temperature changes. Higher temperatures diminish dairy production. Temperatures have both positive and negative effects on cattle production. Higher summer temperatures generally are associated with increased mortality. On the other hand, higher winter temperatures, decreased mortality. Humid conditions generally promote more insect and disease among animal agriculture. In terms of some predictions on major cropping systems, corn and soybean and wheat, for instance. Corn, of course, is a major crop in our country. During 2011, there were 91.9 million acres of corn and 73.7 million acres of soybean. In general, corn is projected without other changes, without changing the variety of corn, when and where it's planted. In general, an increase of 1 degree centigrade is projected to decrease corn production by 8.3%, which is a huge impact economically and in terms of the energy and food supplies that corn support. But then again, the farmers will adapt to this through various means. In terms of wheat, increased temperatures lead to increased rate of development, but there is likely to be a change of latitude for major production areas as they move northward. And in terms of immediate effects, the availability of water for irrigation is likely to have significant impacts on future wheat cropping systems. So in terms of some overall conclusions in regard to effects of these changing climate variables on agriculture, agricultural producers will need to change the types of crops planted, where certain crops are planted, evaluate if irrigation is cost effective, and change how those crops are managed. That's a tremendous change that can create a great deal of economic instability and food insecurity if American farmers, ranchers, and foresters don't get out in front of this with appropriate risk management and planning. Animal production systems will have to be adapted. Rangelands may not be as productive as they were in the past, and significant forest health concerns are likely to remain, perhaps become worse. This creates for us, I'm a science agency, a number of science challenges for NIFA. In terms of science challenges, science across disciplines at scale, which is integrated with extension and education and focus upon impact. Adaptation of plant and animal production systems to climate variables. Downscaled and valid climate prediction models, which we're supporting now. Identifying climate change's effect on water and air resources. Research aimed at improving crop yield potential in anticipation of these changing climate variables. The most immediate concerns we're concerned with are the changes in availability of water and immediate impacts on agricultural production, development of vulnerability assessments and decision tools, and in general, identification of means and methods to improve resiliency or adaptation of agriculture, forest, pasture, and range production systems. Much of what I just reviewed is an excerpt from the USDA draft submitted to the USGRCP National Climate Assessment Office Our report to that office summarizes over 150 scientific studies. It's a very well thought out report. If you contact me directly, I think the report actually came out this morning. I can email you copies of it, approximately 100 pages, and again, good science-based information about the impacts of changing climate variables on agriculture. Next speaker is Daniel Aldrich, AAAS Fellow with the U.S. Agency for International Development. Daniel?
Thank you very much. My own approach to disasters is both personal and professional. It's personal because back in 2005, my house, which was about right there on Canal Boulevard, was destroyed when 15 feet of water came in from the levee nearby. And in the period of unemployment that followed, I had lots of time to think about how disasters impact us individually and as communities. And as a social scientist, my job since 2005 has been to understand around the world what mechanisms increase resilience in communities. The interesting thing for me is this map comes from data we collected, Rick Wheel and I, from around 6,000 interviews with people living in New Orleans. And if you notice, each individual dot is a family or a person, and they're coded as to how they felt about their recovery. Some are green, they felt pretty recovered. Some are red, they didn't feel at all recovered. Underneath that level of households, you'll see a water depth map as well. The yellower areas are more dry, and the bluer areas are more wet. The first thing to notice is that there's no strong correlation between the depth of water and recovery levels. That is, people who had a lot of water in some cases did very well. I'll point out one neighborhood we've been studying a lot has been up in this area. This is Village de l'Est. That community did quite well. Other areas, you'll see no one at all to talk to. Areas we couldn't find on the map people living anymore. They hadn't come back. So we have been concerned for a while, what makes areas better able to bounce back after a disaster? I think there are really 5 main categories that the literature falls into. The first one and most common is we expect that the more money that comes into a community, whether it's aid from a central government, from an NGO, from churches, synagogues, or mosques, we imagine the more money you have, somehow the process of recovery will be a faster and more effective one. But we also recognize that the quality of governance matters. So, for example, after Hurricane Katrina, people blamed the president, President Bush, the mayor, Mayor Reagan, the governor, Governor Landrieu, a number of different people to put on the chopping block afterwards. Economists, though, often look at damage levels. This image comes from the 1923 Tokyo earthquake. I'll talk about that in a few minutes. But the idea of it is quite simple. The more damage done to an area, we imagine the slower the process of recovery. We also seem to think that population density matters. So urban areas, metropolitan areas, will be slower to recover because finding free land for recovery is harder. And also inequality matters. This is an image from Brazil, the favelas. On the left side, you see the dirt-floored shacks. On the right side are condos, each of which has its own pool there. But I think these theories overlook something quite critical, which is that none of them look closely at the inner social networks of these communities. And in the book I have got forthcoming in August of this year, I argue that social capital is really the critical factor in the process of building after a disaster. There are 3 different types of networks. Most of us have friends who are quite similar to ourselves. We call this homophily. Homophily means if you've got a PhD, God have mercy on you, then your friends probably also have PhDs. But bonding social capital, the connection between friends, that's one type of connection. Sometimes we meet people different than us, through churches, through schools, through clubs, through movie theater events. Right? We call this bridging social capital. Bridging social capital takes us between different networks. And occasionally we're lucky enough to have friends who actually have positions of power. So you know someone in the FEMA or Red Cross organization, you know someone in City Hall. We call this linking social capital. And we believe all 3 types of social capital play different roles in the process of recovery. I'll show you quickly now 3 different mechanisms that we've seen. The first decision made by every survivor, whether in Japan after the Tohoku disaster of this year or in India after the 2004 Indonesian tsunami, in all of these disasters, the first choice is, do you go back and rebuild your damaged home, whatever the costs are, or do you find a new community to build in? We call this exit or voice. Individuals with higher levels of social capital, tied into their communities with more friends, with more connections, those individuals we found at least, often use voice and not exit. Individuals with fewer connections to their communities, to their schools, to the local effects, those individuals often use exit. That's the first decision to make. The next process in the recovery one is collective action. A lot of my colleagues, Chamley Wright, for example, of LSU, argues disaster recovery is a collective action problem. How do you motivate everyone to work together when, of course, it's in their best interests to slack off? So we know from experiments in the field and also from data we've been collecting, individuals who are more tightly bound together are ones who better overcome collective action problems. I'll give you one quick narrative from Kobe in 1995 in Japan. There in Japan, the process of recovery, they were offered a freebie from the city government. If every condominium owner signed off on a plan to remove debris, then the city would take it all away for free. But if you couldn't get complete unanimous support from the entire condominium, it would sit there for months. Less than half of the condominiums in Kobe were able to get all the signatures of their owners on board. They couldn't find them. They didn't have email addresses or phone numbers. They didn't know their last names. So the lack of social connections made it very hard to take advantage of this kind of deal. The third and final mechanism we see for social capital is informal insurance or mutual aid. We know after disasters the typical sources of supplies, Walmart, grocery stores, the US government, are often shut down or damaged. So if you want a tool, or if you need food or a place to stay or diapers, it's probably your friends and your friends of friends that have those things available to you. And we found in New Orleans, for example, people with better connections had more access to this kind of informal insurance. I want to mention now very quickly some data we've collected from around the world over the last 100 years from different disasters. If you go back to 1923, with the earthquake there that destroyed roughly half of the city, and you break the 40 neighborhoods of Tokyo into those with high levels of social capital and lower levels of social capital, and then you map over the decade that follows the recovery rate for population, which areas became ghost towns, which areas recovered quite well. We found a very interesting bivariate analysis here, which is that those areas that were more active as a group, with higher levels of bonding social capital, bridging social capital, those areas had higher levels of recovery overall than similar and even less damaged areas that had fewer connections. In other words, population recovery was very much a function not of damage necessarily, but rather of the bonds that had been formed between individuals. We also have data from 1995. This takes two different neighborhoods in a part of Kobe, and they're very small. This is a micro-level study that we did. They're quite similar in population levels and their average age, the number of households, and so forth. But if you look at a few factors that indicate to us the strength of ties, how long you've been living in that community, if you were born in that community, and if you're renting or owning. The people on the right, Fukushima B, they had more years in the community, more than were born there, and fewer of them were renting, more than were owners. We found in Fukushima B, this small neighborhood, this was a much better recovery over time than District 1, as we're calling it, where overall, despite very similar levels of income and so forth, the process of recovery actually was a hollowing out. Most people that we talked to had left within 5 years. One last piece of data from our studies. We went back to the Kobe earthquake in 1995, which killed over 8,000 people, and we had a number of different factors that we studied. The best predictor in Kobe for population recovery across the 9 wards of Kobe over time was the number of non-profit organizations, NPOs, created there. Those communities in Kobe that had worked together to rebuild their individual neighborhoods, those were the ones that were coming back, holding constant damage, income, money from the government, welfare aid, and so forth. All the factors I mentioned earlier. The best predictor of recovery, for population at least, was the strength of social ties. So again, I've got a book coming out in August of this year. But I think, for me, the biggest lessons here are as follows. Despite common theories, folk wisdom about the importance of government aid, for example, or income, folk wisdom about damage and so forth, in fact, across time and space, we found in our studies that the most important process of recovery had been the human connections, the social infrastructure between individuals. People who are better tied together through bonding, bridging, or linking social capital, those individuals are the ones who recover, who get resources that they need, and stay in the communities. Individuals who are more atomized, less connected, who have fewer friends nearby, fewer connections, those individuals tend to leave or cause problems in the process of recovery. This suggests then a new approach to disaster recovery and decreasing the economic toll of disasters, rather than focusing, for example, on the process of insurance or on questions of mitigation. Right? This suggests then our focus should be on building social ties in vulnerable communities. And in fact, right now I'm doing field experiments both in Japan and in Australia with the Red Cross in Australia and with communities in Tohoku, where we're trying to build up through various methods, including, for example, community currencies and focus groups, the depth of social ties in these areas to better prepare them for future disasters. Thank you very much.
Good afternoon. I'm Karl Hedde from Munich Re. I get to go last here and give you a little bit of the insurance perspective, but also show you some real live cases that we're working on where mitigation can be used and mitigation matters. So I have two takeaways that I would like you to walk out of the room with today. One, understand what a reinsurance company is. A reinsurance company insures insurance companies. But two, understand as you put a new roof on your home, and I have a slide up here, have some examples of what you could do to make it a lot stronger and a little bit more water resistance if it blows off. So I want to set the stage first. I'm going to break my presentation into three short pieces. One, just to share some information on natural disasters. This slide shows the numbers of events by year, broken down by the type of loss, so a weather-related loss, a water-related, earthquake-related losses. You could see the trends, and you could see the numbers, and the trend's not going down. Next slide, again, losses by natural catastrophes for the period 1980 through 2011. Here on the blue bar, you see what the insured loss component is. The green bar represents the economic loss. So you can see as a general percentage how much insurance covers of that economic loss. We had the highest number of, or the highest amount of insured loss, fifth highest amount of insured loss in the 2011 year. So the pretty active year as far as insurance claims and insurance losses. I focused one of my charts on U.S. thunderstorm losses. You could see the 2011 total was $25.9 billion from an insured loss perspective. You could see the 5-year running mean from these types of events going up. And the jury's still out as to what's causing this, as far as whether it's socioeconomic or is it climate related. Irrespective of that, I think we have an issue and we have to become, and I'm going to borrow a term I heard a couple weeks ago at an event, a weather-ready nation. We really don't have to argue about what's causing it. What do we need to do, and what do we need to do to mitigate our properties and make ourselves safer. And this is, I think, my final chart on the losses. This one's interesting. This is, again, the 1980 through 2011 period, and it shows insured losses in percentage terms by continent. So you can see where the North American and South American continent takes 66% of the insured losses. Again, is it the types of events that we're subject to in the Americas? Is it the socioeconomic value that's at risk? But again, we wind up paying 66% of the losses worldwide. And I'm going to show some pictures. While I work for Munich Re, I'm also the chairman of the board of a nonprofit organization supported by the insurance industry. It's called the IBHS, Insurance Institute for Business and Home Safety. The organization's been in existence for quite some time, but over the last few years, we built a large wind research facility in Chester, South Carolina. Essentially, it's the largest wind tunnel in the world. We have 105 electric-powered fans that are 6 feet high. We could generate wind speeds of around 135 miles an hour now. And in this case, you could see 2 full-scale homes. They were each around 1,500 square feet next to each other. I was standing right around where that camera is taking that photo. We ran 3 tests. The first test was to see if the facility and the fans actually worked. And the second 2 tests were one for the CEOs and senior management teams of the companies that supported the building of this research facility, and the other one for the press. First time we ran the test, we were standing there, we had no idea what would happen. These are 2 homes that were built to building code, Midwest building codes. They're new construction. I think it was building code was the state of Illinois. and at around 95 miles an hour, it happened so fast that one house blew down. And my initial thought was, what if you or your family was in that home? You had a brand new home, it was built to code, and no one would have expected it to blow away that day. The one on the right is about a $3,000 difference in cost, just some basic differences: wind-resistant roofing, wind-resistant siding. The key on this one was the door on the right opened out, so the front door opened out. The pressure pushed the door against the frame. The other one, the door on the left, opened in. There was hurricane strapping on the house on the right, minimal hurricane strapping on the house on the left, again built to code. So total cost difference, $3,000. Huge difference in the cost of not just the building being blown away, but the life safety issues of what's happened here. The research facility is able to do wind, hail, fire, and wind-driven water. Here's a case of they worked with the fire service last year to do a number of tests, figured out how to generate blowing embers. These are most likely blowing at around 25 to 30 miles an hour, so the fans were blowing. The fans are over on the right-hand side there. They built a full-scale house with all different siding and different roof material. High-def cameras in the eaves, in the attic of the building, as well as the inside of the building. It was very interesting to watch a building catch on fire and what caught and what didn't catch. Ultimately, they stopped this fire before they burned the whole house down inside. My fear is that we would have damaged our research facility, but and the local firemen were there. They were enjoying themselves. They got to put out the fire that day. But again, a lot of the roof survived. But this was, again, we had some wood shake shingles on the roof that were fire treated. They actually, a couple of them burned through, and embers dropped into the roof attic area. So this would have, if let to go, this one would have burned down. We're learning so much, and this is a case of a picture's worth 1,000 words. The first picture was very powerful. This one, if you don't see inside the house of what's happening, it's not as powerful. But if you saw the video of what's happening inside the house, extremely powerful as a tool to help and really hopefully change behavior, change people's behavior as far as how they build, what construction types they use, building codes. There's an awful lot that's going to be informed out of this research facility. And we only started using this the summer of last year. So this is, I think, is going to have the same impact that the Insurance Institute for Highway Safety had on car safety. This is ultimately going to have the same impact on homes. The problem is people don't buy a home every 3 or 4 years. It's going to take us a lot longer to change the stock, the building stock in the homes. Here's my last picture that I'm going to show, and this one is, I'm going to talk a little bit about what you should do when you put a new roof on. Here's a case. The house was built, same types of roof shingles. This one was most likely subjected to 120 to 130 mile an hour wind speeds. A lot of the shingle, the roof shingle, has blown off purposely. You can see on the left side of the house there's taping on the seams of the roof material. On the right-hand side, it's just the roof material has been placed in there. In this test, they also subjected it to wind-driven rain, and a lot of wind-driven rain. And they had video cameras and collection devices set up inside this house. This house was fully furnished, and if you had the camera inside, once that roof material blew off, the side of the house on the left didn't leak, and as a result, the ceiling didn't collapse, and the contents within the house did not get damaged. The side on the right, not taped, not protected for water intrusion, leaked like a sieve, and the ceiling ultimately collapsed. So we're learning an awful lot here. If you have a roof replaced, tape it. When they take the roof off, don't roof over roofing. A lot of us do that to save a few dollars. Don't do that. And when the roofer is up there, have him re-nail the roof with ring shank nails. So a couple simple mitigation items, and roofs get replaced. I don't know if everybody knows, and I didn't know this until recently, that the insurance industry is the largest consumer of roofs. They essentially pay for about 50 to 60% of all roofs replaced in this country. And now if we could get the insurance companies to put better roofs on buildings, we'd be in a lot better position. But due to our state regulation, we can't talk to each other, so somehow we're trying to have to figure out how to send Morse code to each other. My last section of my presentation deals with a study that was prepared by the IBHS this year. And one of our earliest speakers this morning talked about grading. And what we've done at the IBHS is developed grades for the coastal exposed states, taking into account the building codes that they have in place, the enforcement mechanism, and one thing that was very important was the actual licensing and control of contractors. And I have an easier to read slide because I'm sure everybody wants to look at where their state is and what grade we're getting. I'll go just quickly talk about what's in the report. It was focused on the residential code regimes, 47 different data points that the IBHS, through their research, has felt has been important. It was code adoption and enforcement was 50% of the grade. Implementation via code officials was 25%. Contractor, subcontractor licensing, 25%. Each state has a numeric score and description, and we have a 100-point scale, so 100 is equal to the best. This report was put out about 8 weeks ago. Before the report was put out, the board of directors of the IBHS got together and said, okay, we're going to create big problems for ourselves within certain states. We weren't sure, but we all decided it was well worth the effort and the impact that this would have. Now think about, and I'll go to the final report card, Florida is the top-rated state. The states in this area, Virginia, Maryland, are pretty highly rated. Maryland was at 73 and Virginia was at 95 as well. You can see the component. What shocked me here was Delaware at a rating of 17. They only got 4 points for code and they got 13 points for contractor licensing. We've already gotten a call from, I think it was the Department of Insurance in Mississippi, complaining about their grade and how come they didn't get points for the code. We said you didn't have a code, so it's tough to give you points. Couple vantage points here. We see and we continue to see problems with states enacting building codes. Hopefully this forces some discussion at the state level. It should force discussion at the consumer level. Do you want you or your family to live in a state that has a code that's not building a safe home, ultimately? And you saw what happened it was based on that Illinois code, that house blowing away at 95 miles an hour. So within the insurance industry, we're taking a number of steps. I think the wind research facility is going to really help, one, develop the research, but the picture is going to be worth 1,000 words. The pictures are powerful. And this is the first time we're able to test full-scale homes. And even the engineers at the research facility are learning things that haven't been seen on the small model tests that have been done in the past. A couple of weeks ago, I mentioned the research facility does wind. It does wind-driven water, fire, and last week, 2 weeks ago, we ran our first hail test. They've developed a method to make various size hail stones, a delivery mechanism, and they shot thousands of hailstones at a roof over about a 3 or 4 minute period. We're able to test different types of roof material. That you'll see a little bit more over the next few months. Keep an eye out on some of the major networks. I think it's July 17th. There's going to be a wind test of a commercial structure, actually a masonry structure that we expect half of it to blow down and half of it should stay standing. So we're taking some very good steps on taking steps to build better and safer structures, both on a commercial as well as the personal line side. Good, thank you.